Did you know that the world's longest bridge stretches over 102 miles? That's longer than the entire coastline of some countries. Bridges are more than just structures that help us get from one place to another. They are engineering marvels, connecting communities and pushing the boundaries of what's possible. From ancient rope bridges to modern architectural wonders, bridges have played a crucial role in shaping our world. This essay will explore the fascinating process of how these structures are built. We'll unravel the mysteries behind their strength, stability and longevity. By understanding the steps involved in bridge construction, we can appreciate the ingenuity and hard work that goes into creating these essential pieces of infrastructure. So buckle up and get ready for a journey into the world of bridge building, where engineering meets artistry and innovation knows no limits. Building a bridge starts long before the first piece of steel is lifted or concrete is poured. The planning phase is crucial, involving a team of engineers, architects, geologists, and other experts. The first step is to determine the purpose of the bridge. Will it carry cars, trains, pedestrians, or a combination? What is the expected volume of traffic? Next, the site is carefully surveyed to understand the terrain, soil conditions, and potential environmental impacts. Engineers analyze the strength and stability of the ground to decide what type of foundation is needed to support the bridge's weight. The location of the bridge also influences its design. Is it spanning a river, a valley, or a busy highway? Each scenario requires specific considerations. The planning phase also includes budget considerations, environmental impact assessments, and obtaining necessary permits. It's a meticulous process, ensuring that the bridge is not only structurally sound, but also sustainable and blends seamlessly with its surroundings. Once the planning is complete, the design phase begins. Here, engineers decide what type of bridge best suits the location and purpose. There are many different types, each with its own advantages and disadvantages. Beam bridges, the simplest type, consist of horizontal beams supported by piers or abutments. They are suitable for short spans and relatively flat terrain. Arch bridges, known for their elegant curves, transfer the load outwards to the abutments, making them strong and capable of spanning longer distances. Suspension bridges, like the Golden Gate Bridge, use cables suspended from towers to support the deck, allowing for the longest spans. Cable-stayed bridges are similar, but use cables directly attached to the towers. Choosing the right bridge type depends on factors like the span length, the load it needs to carry, the ground conditions, and the overall aesthetic appeal designed. Engineers carefully consider these factors to select a design that is both functional and visually appealing. The choice of materials is another critical aspect of bridge building. Steel is a popular choice due to its strength, durability, and ability to withstand tension and compression. Concrete is another common material known for its compressive strength and affordability. It's often used in combination with steel reinforcement bars to enhance its tensile strength. Other materials like timber, stone, and even bamboo are used in bridge construction, often in specific contexts or for aesthetic purposes. Timber bridges, for example, can be aesthetically pleasing and environmentally friendly in certain settings. Stone bridges, while historically significant, are less common in modern construction due to their weight and limitations in span length. The choice of materials depends on the bridge design, the expected load, the environmental conditions, and the budget. Engineers carefully evaluate each material's properties to ensure the bridge's longevity and safety. Section 5. Foundations anchoring the structure. Before the bridge itself can be built, a solid foundation must be laid. This is arguably the most crucial part of the construction process. The foundation transfers the weight of the bridge to the ground, ensuring its stability. Depending on the soil conditions and the bridge's design, the type of foundation used can vary. For bridges built on solid ground, spread footings are commonly used. These are wide, flat concrete pads that distribute the load over a large area. In areas with softer soils, pile foundations are employed. Piles are long, slender columns driven deep into the ground to reach more stable layers. Constructing the foundation requires careful excavation, precise placement of reinforcement steel, and pouring high-quality concrete. This phase often involves heavy machinery and skilled operators, all working diligently to create a solid base for the bridge to stand on. Section 6. Building the deck, creating the roadway. With the foundation in place, the construction of the bridge deck, which is the part we drive or walk on, can begin. For beam bridges, prefabricated steel or concrete beams are lifted into place and secured to the foundation. For arch bridges, the arch is carefully constructed, often using a temporary support structure until it can support itself. Suspension and cable-stayed bridges involve a more complex process. Towers are erected and then cables are strung between them. The deck is then suspended from these cables piece by piece. This process requires precise engineering and specialized equipment to ensure the cables are tensioned correctly. Building the deck involves meticulous welding, bolting, and concrete pouring. It's a carefully choreographed process, ensuring the deck is strong, stable, and capable of handling the expected traffic load. Section 7. Towers and cables reaching new heights. For suspension and cable-stayed bridges, the towers and cables are the defining features. Towers are typically built from steel or concrete and are designed to withstand enormous forces. They are anchored deep into the ground through the foundation and rise high above the water or valley below. Cables are made of high-strength steel strands woven together to form a thick, flexible rope. They are anchored to the towers and the deck, carrying the weight of the bridge. The tension in the cables is carefully calculated and adjusted to ensure the bridge is stable and balanced. The construction of towers and cables is a testament to human ingenuity and engineering prowess. These elements push the boundaries of what's possible, allowing bridges to span vast distances and connect communities in remarkable ways. Section 8. Putting it all together. Construction techniques. Bridge construction utilizes a wide range of techniques, often involving heavy machinery and skilled labor. Cranes lift massive steel beams and concrete sections into place, while welders fuse metal components together with scorching precision. Concrete is poured into carefully constructed forms, creating the deck, piers, and other structural elements. For bridges built over water, temporary structures like cofferdams and barges are used to create dry work areas. Cofferdams are watertight enclosures built around the foundation site, allowing workers to excavate and pour concrete below the water level. Barges serve as floating platforms for construction equipment and materials. The construction process is a carefully orchestrated ballet of engineering and manpower, where each step is critical to the success and safety of the final structure. Section 9. Finishing touches, safety and aesthetics. Once the main structure is complete, the finishing touches are added. This includes installing railings, lighting, drainage systems, and road surfaces. These elements not only enhance the bridge's functionality, but also its safety and aesthetic appeal. Safety features are paramount in bridge design. Railings prevent vehicles and pedestrians from falling off the bridge, while lighting improves visibility at night. Drainage systems prevent water from accumulating on the deck, reducing the risk of corrosion and skidding. The aesthetic aspects of a bridge are also important. Bridges are often seen as landmarks and symbols of a city or region. Architects and designers work to create bridges that are not only structurally sound, but also visually appealing, complementing the surrounding landscape and enhancing the overall built environment. Section 10. The impact of bridges connecting our world. Bridges have a profound impact on our daily lives. They facilitate transportation, connect communities, and boost economic growth. Bridges allow us to travel efficiently, reducing commute times and expanding our access to goods and services. They link people and businesses, fostering collaboration and cultural exchange. Furthermore, bridges play a vital role in emergency response and disaster relief. They provide crucial transportation routes for emergency vehicles and aid workers, enabling them to reach affected areas quickly and efficiently. In times of natural disasters, bridges can be lifelines, connecting isolated communities to essential resources and support. The impact of bridges extends beyond their practical functions. They often serve as architectural landmarks, inspiring awe and wonder. Bridges can be symbols of progress, innovation, and human ingenuity, reflecting the aspirations and achievements of the communities they connect. Section 11. Conclusion: the future of bridge building. As technology advances and our understanding of engineering principles evolves, the future of bridge building holds exciting possibilities. New materials, such as high-performance composites and advanced alloys, promise to make bridges even stronger and more durable. Innovative construction techniques like 3D printing and modular construction could revolutionize the speed and efficiency of bridge building. Furthermore, the integration of smart technologies is transforming the way bridges are monitored and maintained. Sensors embedded in bridges can detect structural changes, monitor traffic flow, and provide real-time data to optimize performance and safety. This data-driven approach allows for predictive maintenance, preventing potential issues before they arise. The bridges of the future will be more than just transportation links. They will be intelligent, sustainable, and resilient structures, seamlessly integrated with their surroundings and enhancing the quality of life for generations to come. If you've enjoyed exploring the marvels of bridge building with us, make sure to subscribe to our channel for more fascinating insights and updates.